Okay, AP Calculus AB Unit 4, Day 9, Office Hours. This is the pretest for the test coming up. So, I guess first I'll try and give you an opportunity to check your answers. So you're going to need to pause the video and then check your answers. So here's number 1, 2, and 3. I'll show you 4 in a second. And then skip over to 5, 6, 7, 8, 9, 10, 11, 12, 13. And then number 18, that's 18 right there, that graph. Number 19, A, B, C. 20, 21, 22, 23. I'll show you the work for that later. 24, 25, 26. So I'm going to scoot it up now. We paused it. And here are the rest of the answers. Number 4, A, B, C, D, E, F, G, H. Pause it if you need to. I'm going to show you 27, 28. Flip it up. Here's 27 and 28. Okay, so, all right, let's do these. Okay, so slope of a secant line is like a line connecting 2 points on a curve. It's like an estimate for a tangent. So slope of the secant line is going to be the y value of 4 minus y value of 1 over the change in the x value is 4 minus 1. It's rise over run. So we plug 4 in here, you get 1648 plus 8, 76. Minus you plug 1 in, you get 5 over 4 minus 1, 71 over 3. I think I made a mistake somewhere. 48 plus 8 is 56. But that's exactly why you want to show your setups, so that if you make some silly mistake like that, you're getting a lot of the points for at least knowing how to set it up. Okay. Slope of the tangent line is the actual slope of a tangent line, which requires a derivative. So f prime of x equals 6x plus 2. So f prime of 2 equals 6 times 2 plus 2 is 12 plus 2 is 14 is the slope of the tangent line. Okay. The equation of the normal line, well, the slope of the normal line is perpendicular to the slope of the tangent is perpendicular to the tangent line. So it's going to be 1/14 negative reciprocal. And then you need x and a y pair, which I think we don't have those yet. So I guess we should plug in 2. And that would give you 3 times 4 is 12 plus 4 is 16. So it's going to be y minus 16 equals negative 1/14 times x minus 2. And just leave it. Please leave it in point slope form. You don't want to do all the extra work. You don't have time. And you don't want to lose points for something you already could have got full credit for. Okay, now we have graph with an xy known pair. We have the known slope. The x-intercept of the tangent line. Well, let's find the tangent line first. Y minus 7 equals 2 times x minus 3. Now, this would probably be a good problem to go ahead and change it to slope-intercept form, because we're going to do something with it afterwards. Okay. Now, that's the slope of that's the equation of the tangent line. Here's the equation of the tangent line. We want the x-intercept, which means you set y equal to 0, and you solve. So the x-intercept is negative 1/2. The y-intercept would have just been 1, which I think I asked you on the other side. Okay, number 3, we're doing it the long way. This is the one problem you're doing long way. It looks like the definition of derivative, it is purposely wrong. Plus, it's a function that you probably wouldn't be great at taking the derivative of yet anyways. So I want you to do it the long way. So very proper here. You got the limit still. We're going to plug x into there. It's 4 over 3 minus 2x minus. I'm going to plug x minus h in for the x in parentheses. I would definitely do parentheses all over 2h. Now it's going to equal limit as h goes to 0. I'm going to think of that as over 1. So it's going to be 4 over 3 minus 2x minus 4 over 3 minus 2x plus 2h times 2h over 1. Okay, we want to combine these together. You know, the whole point here is that, you're getting 0 over 0. So we're trying to factor the whole out. That's the long way. So equals the limit as h goes to 0. We need to multiply top of this one by that. And give them least common denominator. So it's going to be 12 minus 8x plus 8h minus 4 times this is going to be 12 plus 8x all over 2h. 3 minus 2x. 3 minus 2x plus 2h. Let's clean it up. Combine like terms on the top. Now, remember the whole point of this is to somehow factor out at the whole, which we definitely know is at h, so we need to get an h out of everything at top. So anything that doesn't have an h should go away. 12 minus 12, negative 8x plus 8x. If that doesn't happen, something's wrong. So there's the whole in the graph. So now you plug in h equals 0, and now we're not going to write the limit in the next step because we've done the limit. It's going to be 8 over 2 is 4 over 3 minus 2x. 3 minus 2x, so that could be your answer. Or you could write it like this if you want. A little more compact. I guess you could FOIL the bottom out unnecessarily, but whatever. Something like that. So that's what we're looking for in that problem. We got some graphical limits. These should be fast, but add up to a good chunk of points, so be careful. Most of these should be like lining up to probably nice points. So f of 8 is 0. Value of the function. Now the limit as we approach 8 is different. Both sides agree that it's going to 3. Two-side limit. 7, one side's blown up, other side it does not exist. Two sides have to agree, and you can't go to infinity. As we approach 3, same thing, does not exist. You might say, oh, well, they both go to negative infinity, which I may have had on my answers, but we're not going to do that. Now, if it's a one-side limit, sure. As we go to infinity, positive infinity, it looks like it's going to this horizontal asymptote value of 1. Okay. Part F, letter F, is a derivative, and so is G, so be careful here. We're approaching 3 from the right side. The graph is going to negative infinity, but the slope is equal to positive infinity. That's a positive slope. That's going up. Left to right, that's going up. So that's going to be positive infinity. Technically does not exist, but this is the one I want. That's a one-side limit. As we go to infinity, the slope of the graph is going to a flat line. The slope is going to 0. True or false is the limit as x approaches 0, f of x equal f of 8. Well, what's the limit as x approaches 0? Both sides agree. It's 3. What's the value of f of 8? 0. Well, then false. So true or false? I need to see something backing up your answer. All right. On to the next page. A bunch of algebraic limits. Some of them I'm going to ask you to do two ways. So that means including L'Hopital's rule. So I'll tell you which ones on test day. Probably ones that give you 0 over 0 that are factorable. So, probably like 7 and 8. I'll have you do 2 ways. First things first, plug in -2, you get -8, -16 minus +4 is -20. Super easy. Sometimes it's not hard. This is going to be 7, right? This one's going to give you 0 over 0, which is an indeterminate form, which means there's probably a hole in the graph, so we could try to factor it. This is a difference of cubes. You could do synthetic division if you want, but you should probably also know how to factor difference or sum of cubes. X squared, 2 squared is 4, in the middle 2x, same, opposite, always positive. That's the whole. Plug 2 back in, 4 plus 4 plus 4 is 12. The other way is going to be L'Hopital's rule. So probably on your test, I'll have you guys label your work, and so we're going to take the derivative of the top, 3x squared, and the derivative of the bottom, 1, plug 2 in, and get 12. You should get the same answer both ways, unless you did something wrong or you're not supposed to do L'Hopital's rule. This is going to be a plus 4. 12 minus 12 is 0 over 0. Now you got to show this to use L'Hopital's rule. I'm looking for this in your work. This is the thing that's telling you to try and factor a whole out. If you don't get this, then all these other strategies don't even make sense. Now, I think we need to do a little synthetic division here to get this x minus 2 out of here. 1, 1, 0, negative 12. Drop the first number, multiply by 2, get 3, add, multiply by 2, add, multiply by 2, add. You should get a 0 at the end, otherwise something's wrong. So then we're going to do the limit as x approaches 2 of x minus 2. That's what you just factored out. X squared plus 3x plus 6 over x minus 2. There's the hole in the graph. Plug 2 back in, you get 4. 6 plus 6 is 16. Otherwise, we could do L'Hopital's rule, which I will probably ask you to do both of these methods. Limit as x approaches 2. Derivative of the top is going to be 3x squared plus 2x. Derivative of the bottom is going to be 1. Plug 2 into this, you get 12 plus 4 is 16. There you go. Makes sense. Okay, next one. We're approaching 3 from the right side. If we just plug 3 in, we get 6 over 0, which means we're going to get some kind of infinity. Is it positive or negative, though? We're approaching 3 from the right, so it's like 3.0001. So that's a positive small quantity, so that's positive infinity. That's the work you could show. This one is going to be 16 over 0, so some kind of infinity, positive, negative. Well, we're approaching 4 from the left side, 3.999 minus 4 is going to be a negative small quantity, so that's going to be negative infinity. Number 11, we're approaching infinity. It's called in behavior. The top goes to positive infinity, the bottom goes to positive infinity. We're looking at dominant terms. Now, the top, we should get a positive answer, 1. 2, the top is blowing up way bigger than the bottom, so the whole thing's going to go to positive infinity. And that's enough work to show me. Circle this thing, show me that, you're doing. We could do L'Hopital's rule. I'm probably not going to ask you to do L'Hopital's rule on this because it's really annoying. And I don't think we ever would for in behavior. 21x squared over 12x. You get positive infinity over positive infinity again. Gotta do it again. Limit as x goes to infinity. 42x over 12, and then it's going to positive infinity. So probably won't ask you to do L'Hopital's on that. Up here on number 12, you guys should remember something special about these. Dominant term is going to positive infinity over negative infinity, because there's a negative right there. We better get a negative answer. Square root of this is 3x, and if we just compare these, we would say the answer was -1. But there should be absolute values around this, which force it to be positive while that one's negative, and we get -1 still. So I guess the absolute value thing, I'm looking for the absolute values anyways. So it was -1. Okay, next one, dominant term. It's positive infinity over positive infinity. We should get a positive answer. Now this one we could say, well, the dominant terms is going to be square root of 2 times square root of x over square root of 8 times square root of x. So they have the same degree, so it's going to be the ratio of their coefficients. The square root, you can combine them together, 2 over 8, which is 1 over 4, which is 1/2. Should be positive. Okay, next one. If tangent is sine over cosine, and so you're going to get 0 over 0. Okay. Probably not going to ask you to do L'Hopital's rule on this because it involves stuff that you guys aren't good at yet, derivatives. I want you to use, we're not going to be able to factor the whole out either. So I want to use that trick where we get the sine of x over x, or sine of something. Now this is going to have a cosine on top because it gets flipped, and a sine on the bottom. So I separate everything. Now that could just be a 1. Now I want this to have 4x and this to have 6x. The x's balance each other out. I need another 6 here to balance the 6 out. I need another 4 here to balance that out. That's going to be 1. This is going to be 1. This is going to be 1. The cosine doesn't have any problems. Please don't do that with the cosine. That does not help. The answer is 4 over 6, or 2/3. Okay. Next one, piecewise function. I'll probably want you to do the two one-sided limits as x approaches 3 from the left. We're going to get the limit as x approaches 3 from the left of x squared plus 5, which is going to be 9 plus 5, which is 14. And then we do the right side limit. Limit as x approaches 3 from the right of f of x is going to be specifically limit as x approaches 3 from the right of the function that's valid there, which happens to be the same, which is unusual. Gives you 14. They're both 14. So the answer is 14. That's the kind of work, though, that you can show. Now, 16, 17, these are the ones that you want to use a shortcut for. You should realize this is a derivative. You could do this long way. I really don't want you to. You don't have time. You're going to make mistakes. What is it the derivative of? X to the 5th. What's the derivative of x to the 5th? Using the rules you've memorized, 5x to the 4th. Now, plug 2 into it. That's what the 2's are. That's usually where the x's are. So 2 to the 4th, 16 times 5 is 80. That's the quick way. So in here, this is a derivative of what function? Absolute value of x. What's the derivative of that? Don't know. Then we got to plug in -4. So this is one that I personally, I mean, you could rewrite this as a piecewise function, do it all technically right, but I'm totally cool with, let's graph this. This is what absolute value of x graph looks like. And we want to know what's the slope at -4 over here. It's -1. Right? Easy. But draw the graph if that's the way you're going to do it. Otherwise, you could do a piecewise function. You say, well, f of x equals, you got to get rid of the absolute values to take derivatives. X when x is greater than or equal to 0, -x when x is less than 0. The derivative then piecewise would be 1 when x is greater than 0, and -1 when x is less than 0. So therefore, f prime of -4 would have to be -1. I mean, I guess if you want to show that, that's a little tougher, I think, than just drawing a picture and saying, hey, that slope's -1. So you're going to have quite a few algebraic limits, some of which I'll ask you to do 2 ways with L'Hopital's rule. And in addition, you're also going to have a problem like this next one, position versus time graph. And so your graph needs to be realistic in the sense that it should be a smooth graph, no corners or abrupt turns, and you got to kind of follow the description here. Now, the height of your graph could be a little different than mine, but I want to see nice dots at all the times. So sketch position, it's initially at rest, so it needs a 0 slope. And this is where it's at. Solid dot accelerates rapidly until t1 seconds. So it's going from a 0 slope up concave up would be a positive acceleration, get steeper and steeper and steeper. Then it maintains its speed until t1, so that means it should be extension of that line, straight line though. So it kind of depends on how you draw that first part. Mine's going super high just because I got to a pretty steep slope. And then it slows down, t3, slows and finally stops, so something like this. And then at t4, it begins to return home. So between t3 and t4, it's not moving at all. So that's a horizontal line. And then steadily increasing rate. So it's picking up speed, but in the negative direction. 3/4 of the way home, the car suffers engine failure. So 3/4. So I'm up here. So 3/4 for me, or 1/4 left, probably be something like around there. So at t5 comes to a stop very suddenly. So this is getting steeper and steeper and steeper and steeper, and then little tight turn there, and then it must not be going anywhere until t6. So we'll do it flat. So this is what I'm looking for, something like this. Your graph should have the same shape as this, pretty much. It could be a little taller, shorter, but I need to see those dots. Okay, 19, kinematics. This is motion and one-dimensional motion, and we're dealing with gravity here. I'm giving you the gravity problem just in case I ask you to. It's negative 16t squared plus v naught t plus s naught. That's the formula for gravity, motion, vertical motion due to gravity near the surface of the Earth, neglecting other things like air friction. So what's the height at 3? This is the height function. S is for position. We could also use y. So h at 3 would be, we're going to plug 3 into this. So 144 plus 360, 384 plus 6 would be, plus 390 would be 146. And it doesn't have any units here. I mean, I don't know, feet per second if it is gravity, but if I don't give you units, I guess that's fine. It does have units for time, but not necessarily for height. So, but I actually made a little mistake there. 246. Guess I should be a little more careful. Maybe do less stuff in my head. I didn't need to do that. 8 minus 4 is 4. 3 minus 1 is 2. 246. Okay. Find V bar. That's the average velocity. And what we've said is that's the average derivative of a position graph. And to find the average slope of a bunch of different slopes between 2 points, you just connect the endpoints and find that slope. So it's just going to be S4 minus S1 over 4 minus 1. It's the slope of a secant line. So S4, which it's going to be a big number. I guess we should figure that over here. Maybe it's going to be 16 times 16 plus 128 times 16 plus 6. So that's going to be 16 times 16, I think it's 256. 6 times 6 is 36, carry the 3, 9, 0, 6, 1, 6, 15, 256, negative 256. 16 times 128 would be 48, carry the 4 to 12 is 16, carry the 1 to 6, 7, 0, 8, 2, 1, 8, 14. 2048 plus 6. So 2048 plus 6 would be 14. 2054 subtract 256 would be, borrow from that, 14, that'd be 8. You have to borrow from that. That's a 10 now. 9. 14 minus 5 is 9. 9 minus 2 is 7. 1. So 1,798. Does I make some horrible mistake? Oh shoot! Gosh dang it! There should have been a 4 right here. I would just put 16 here because I did 4 squared, and this should have just been 4. So this is gonna be 256. This should have been 512. That makes life a lot easier. So this is just ignore all that. So it's gonna be 518 minus 256. So 12. 8 minus 6, 2. 11 minus 5, 6. 262. 262. So 262 minus 1, I think is easy, a lot easier to do in my head. That's going to be negative 16 plus 128. So it's going to be 112 plus 6 is 118. 4 minus 1. So it's going to be 144 over 3, which is actually nicely 48. Okay. Got a little stuck in all that. The velocity at time 3. So we're going to, well, we haven't found a velocity equation. We just found average velocity. Velocity is the derivative of position. So it's going to be negative 32t plus 128. So we're going to plug 3 into that. Negative 96 plus 128 equals 32. Velocity when the position is 220. So the keyword is we got to figure out the time and then plug in the velocity. That'll be the easy part. The hard part's finding the time. So we're going to take position, which we have an equation for, and set it equal to 220 and solve for the time. So we're going to move everything on one side. Equal to 0. And we're going to try and factor it. I think we take a 2 out, and that's 1. So I think all we can do is take a negative 2 out. So t squared, but that's helpful still. Minus 64t plus 107. And then I don't think we can factor that. So we got to do quadratic formula. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's not pretty. 64 plus or minus. Now, what's 64 squared? 64 times 64 is 16. Carry the 1 to 24 is 25. 24 carry the 2 to 36 is 38. Should have been an extra 0 there. So that's 6, 9, 4,096 minus 428. So 16, that's 8. 8 minus 2 is 6. 6, 30. We're going to take the square root of that. Now, the square root of that, I feel like I made another mistake somewhere. Let's see. Oh my gosh. Should be 8 here. 2a. This would be 8 here. Being careless. Going too fast. 32 times 1 is 7. 14, carry the 1. 1, 2, 0. 21, carry the 2. 2, 3, 4, 2, 4, 3. So we should have done 4096 minus 3424. It's going to make life nicer. 2, 7, 672. And so then, so it's 64 plus or minus the square root of 672 over 2. Now, 2 times 336, 2 times 168, 2 times 84, 2 times 42, 2 times 21, 3 times 7. Prime factorization, pairs of 2s are going to come out. So I'm just trying to simplify this. 64 plus or minus 4 square root 42 over 2 equals, we can now divide the 2 into both of these. 32 plus or minus 2. So one answer is 32 plus 2 square root 42, and then the other one is 32 minus 2 square root 42. And these are approximately, that's positive. We're usually avoiding negative answers on these problems. So I think we're going to not use this answer because square root of 84, that's like our 160. Well, I feel like that'd be a positive answer still anyway, so maybe we should do both. Square root of 42 would be, oh, by the way, on the bottom I messed up. This is supposed to be 16, and I never fixed that. So this is going to be a 1. We're going to take a 4 out, and a 4 out of this, so that's going to be 16. So square root of 42 is between 36 and 49. So it's right, 6.7. So this is probably around 10 fourths, this is around 10 fourths, and this is around 22 fourths. So I think we should probably just go ahead and do both answers, but we got to plug them into the velocity equation now, which we found up here, which is a little messy, but not as crazy. So 16, it's going to be negative 32 times 16 plus square root of 42 over 4 plus 128. So that's going to give you 8. So that's going to give you negative 80, 48, 128 minus 8 square root of 42 plus 128. It actually works out really nice. It does cancel out, and we get negative 8 square root of 42. And then the other answer would be negative 32 times 16 minus square root of 42 plus 128. And that's going to be 8. And so that's going to be negative 128 plus 8 square root of 42 plus 128. And so the other answer is going to be positive 8 square root of 42. There's units, that's velocity of b feet per second. When is the velocity positive? Well, you want to take your velocity equation, which we already found earlier, negative 32t plus 128, and set it greater than 0, and just treat this like, do a line check or something. 32, we could just solve it. Be careful when you're moving stuff around on inequalities. And so we could just say, oh, t is less than 4. Or we do a line check, which might be more likely for a more complicated problem. Set equals 0, find t equals 0, or find velocity equals 0 times 4, test a point. T equals 0, positive, negative. This is where it's increasing. Now, you might say negative infinity to 4, or that, but it might be more appropriate to say 0 to 4, because if we don't take negative time. Okay, find the velocity when s equals 4, so that's similar to part D. So we're going to take our s equation and set it equal to 4. And then move everything one side, equals 0. Factor it if we can, or as much as we can, to get negative 2 out of everything. At squared minus 64t plus 1. Factor if you can, but don't think we can, so we're going to do another quadratic formula, negative b plus or minus the square root of b. Sorry, I'm already making mistakes. I was trying to be extra careful. B squared minus 4ac over 2a. So it's going to be positive 64 plus or minus. I think we did 64 squared already. It was 4096 minus 32. So that's going to be 4064. So 2 times 2032, 2 times 1016, 2 times 508, 2 times 254, 2 times 127, which 3 and 9 don't go into 2, so pairs of 2s. Pairs of 2, so this is going to be 64 plus or minus 4 square root of 254 over 16. We could reduce it to 16 plus or minus square root of 254 over 4. In this case, I think the negative answer is still okay, I think, because 254, 225 is 15 squared. 16 squared would be 256. So it's definitely less than 16. So I guess we're going to have two answers. We're going to have 16 plus and 16 minus. Hopefully I make them a little cleaner on your test, huh? I mean, the idea should be the same. So we're going to plug those into your velocity equation. So that's going to be negative 32 times, let me just double check, make sure I didn't make any mistakes here. Okay, I think I might have wrong answers in my answers. So I guess we'll work them out right now. 16 plus square root of 254 over 4 plus 128. It's going to be 8. So 8 times that, 80. 48 be negative 128 minus 8 square root of 254 plus 128. Those cancel. So the answer should be negative 8 square root of 254. That should be one of your answers. And then the other one negative 128 plus 8 square root of 254 plus 128. So, I mean, surprisingly cleanish answers. So those would be your two velocities. I think my answers on my solutions were wrong. Okay. All right, getting there. I just have a couple derivatives up here, just power rule. So it's going to be 4x cubed minus 18x, and the pi goes away because it's constant. Don't put plus 2 pi to the first. And derivative this. It's going to, well, this one, what I would probably do is multiply it out first. So that'd be 6x cubed minus 8x squared plus 15x minus 20, and then take the derivative. That'd be 18x squared minus 16x plus 15. This, I would rewrite it as 2x to the negative 3/4 power. That's what it is. That's the same function. And then take the derivative using the power rule. It's going to be negative 6/4 x to the negative 7/4. You got to take one away. If it's already negative, you got to take it away. A cleaner answer would be without negative exponents, which I usually desire. It would be negative 3 over 2 fourth root of x to the 7th, or negative 3 over 2 x to the 7/4, or something like that. I don't really, yeah. Prove the power rule. Well, we did that in class in the notes. Take a look back at the notes. We used Pascal's triangle. And we kept going. We noticed that it was always an n was the second number. So the function is x to the n. And we know that the derivative should be in x to the n minus 1. So this is what we're trying to prove. So we're going to use the definition of the derivative limit as h goes to 0 of f of x plus h minus f of x, or one of the other versions. I just personally would go with this more common one. So we're going to plug x plus h into our original function, x plus h to the nth power minus x to the nth power over h. This does give you 0 over 0 if you plug it in, so we're going to try and factor the whole out. So we're going to use Pascal's triangle to expand that. So it's going to be a 1x to the nth power h to the 0 power plus n x to the n minus 1 h to the first, plus we know everything else has h squareds in it. So I'm just going to say this because we don't really know. But this is going to be good enough. So, and then we also have a minus x to the n here. So those guys cancel, which we hope will happen. So we can factor the h out. This is like doing it the long way. So we're going to factor an h out of everything. We're going to have n x to the n minus 1 plus h times a bunch of stuff. For h, there's the whole. Reevaluate by plugging h equals 0, and that goes away. And we have n x to the n minus 1. I don't think I'm going to have you prove that rule on your test, but whatever, some good practice. 24 is a continuous differential in either or both. So you want to check for continuity first. That's with the y values equal to each other. So plug 2 in. We get 4 minus 2 is 2. 6 minus 1 is 5. They're not equal, so it's not continuous. So it is automatically also not differentiable. Don't even check the slopes. For sure, don't check the slopes first. You might be misled. The slopes actually end up equaling each other. So it should be neither. If you did keep going and found the piecewise derivative, which you would if things were okay on the first step, then you would do this. And then you would plug 2 into that, and you would say, oh, it's 3 and 3. They're both equal. That's good. And that would usually mean differentiable if it was continuous already. But if it's not continuous, it's not differentiable. 25, find the coefficient of expansion. So this would be using Pascal's triangle. Fifth level, 1, 5, 10, 10, 5, 1. That's one we're going to want to use. I just added it to the Pascal's triangle I wrote earlier. So it's going to be negative 2, 1 x to the 5th, negative h to the 0, plus 5 x to the 4th, negative h to the 1st, plus 10 x to the 5th, negative h to the 2nd, plus 10 x to the, sorry, this should be x cubed, x squared, negative h to the 1st, plus 5 x to the 1st, negative h to the, should be cubed to the 4th, plus 1 x to the 0, negative h to the 5th. You don't necessarily need to find all these terms because we just want, I think, this one right here, but it gets the negative 2. Or you can do it all. This is a 1. It's going to be negative 2 x to the 5th minus 10. Actually, positive because that's going to be negative to the first power, another negative x to the 4th h. That's going to be positive. It's going to be minus 20 x to the 3rd h squared. That's going to become negative, and there's another negative, so it's going to be positive 20x squared h cubed. That's one we want right there. We just want the coefficient, so the coefficient is just the number in front, 20. We can keep going, even though we don't need to. Minus 10x h to the fourth and plus 2h to the fifth. There you go. Find b if this function is continuous. That means the y values have to equal at the transition. So we're going to plug 2 in. And 2 to the fourth is 16. And 2 to the third plus b times 2 is going to be 8 plus 2b. They need to be equal to each other. So we're going to set them equal to each other and solve for b. Subtract 8. Divide by 2. b equals 4. All right, you have to sketch some derivative graphs, probably from some crazy looking piecewise ones. I'd look for zero slopes. That looks like a zero slope there, but it's going to be open dot because there's a corner. This looks like a constant slope at 45 degrees. That's a -1 slope. So that's -1 going to the left forever because there's a little arrow on the end. So we need an arrow on the end of ours. If you have vertical asymptotes, then the slope's going to blow up. It's going to positive infinity. And here it's also positive infinity slope. So both sides are going up. Now this looks like it's approaching y equals 0, but never quite getting there. So it would look like this. It would look like it was also going towards a horizontal asymptote. So that kind of graph. That'd be it. Next one, that looks like a 0 slope there. That looks like a 0 slope there. That looks like a -1 slope. Now I'm putting these open dots unless the pieces connect in a nice, really smooth way, which so far they're not. Vertical asymptote and original graphs can result in vertical asymptote in your. Now this is going to negative infinity, but the slope is positive infinity. So that blows up here. That's a positive slope, left, right. Now this is going to negative infinity, and the slope is going to negative infinity because it's going down. So, and it looks like it's going towards 0 over here. So I'm going to make this graph look like this. All right, there you go. I did the test in 48 minutes. If you show up early or stay later, you could potentially have over 60 minutes. And that's going to be tough for you guys to get all these done. So be ready, prepare for it, and use some good test taking strategies to get problems you're getting stuck on. You know, there's a lot of points throughout it. Some are easier to get, some are harder to get.